Okay, guys, looking at this one, it says, what is the instantaneous velocity of a free-falling object 32 seconds after it's released from a position of rest? We see the acceleration of gravity is 9.8. So writing down what we have for this one, since it's at rest, we know that our initial velocity is going to be 0 meters per second. It gives us a time of 32 seconds. Acceleration, which is gravity, which is 9.8 meters per second squared. And it wants to know what's our instantaneous velocity of a free-falling object. So it's the velocity after it's released. So that is going to be our final velocity is what we're going to search for. So if we do if that, okay, we have our initial velocity. We're searching for our final velocity. We have acceleration. We have time. So we're going to use the equation that does not have distance, which we know that that equation is going to be our acceleration equals our final velocity minus our initial velocity all over our time. Okay, so in that equation, since our initial velocity is going to be 0, we can just go ahead and take that guy out of there, and we're left with this equation. And let's solve for our final velocity. So when we solve for our final velocity, all you have to do is multiply our acceleration and our time, and what we'll get is we'll get acceleration times time equals our final velocity, which when we plug that in, we see that we have our acceleration, which is 9.8 meters per second squared times our 32 seconds equals our final velocity. And we should see the units match up because meters per second squared, when we multiply it by seconds, it's going to give us meters per second, which is a velocity, an instantaneous velocity. And since it's free falling, and it wants the instantaneous velocity, it does want this to be a vector quantity, so it wants you to tell you that since it's free falling, it is moving downward, so our acceleration should be negative. So we would get a negative instantaneous velocity, which mine is right around negative 313.6 meters per second.